So now we're taking a look at part 2 of this graphing lines from an equation set of lessons, and we're taking a look at lines that look something like this: ax plus by equals c. Now, let's not worry about that right now. This will make more sense later. Let's just first focus on this typical line here. Now on this line, which you've drawn many times by now, different slope, different intercepts and stuff. When you look at this line, like from the previous lesson, you notice a few things. One is the slope, how steep it is, and the other thing is where it crossed on the y-axis. That was the y-intercept. There's another thing about this line. Oh yeah, also it leans forward, so it's going to have a positive slope. But there's another thing about this line. We shouldn't only be worried about the y-intercept, so that. We should also, it's handy to know what the x-intercept is. Remember, this is the x-axis, that's the y-axis. So any line that you have is going to slice through the x-axis somewhere and slice through the y-axis somewhere. And since these are all straight lines, and all you need are two dots, if you know what the x-intercept is and the y-intercept is, then you can graph the line. So this, like I've told you already, is the, I'll do it in blue, is the y-intercept right there. And this up here is the x-intercept right there. And what's special about these points? Well, the y-intercept, again, it slices through the y-axis. And so it could be there, a different line, it could be there, there, there. But what all y-intercepts have in common is that as their y values change, but what they all have in common is that they all have an x value of 0. This point here is, what are the coordinates of this point? Well, in this case here, it's 0 on the x-axis, and -4 on the y-axis. An x-intercept is the exact opposite. It slices through the x-axis somewhere. In this case, it slices through at 3, positive 3, and its y value is 0. It's not above or below the point of origin, it's right at 0. So an x-intercept, in this case, the x-intercept is 3 on the x, 0 on the y, which allows us to know a few things. Whenever you want to find the x-intercept of something, it's wherever y is equal to 0. So the x-intercept is found when y is equal to 0, like it is here. Okay, remember the second one is the y-coordinate, the first one is the x-coordinate, it goes xy. And then the y-intercept is the exact opposite. It's where, or when, x is equal to 0. Okay, so x, 0, -4 is the y-intercept. So what we're coming up with here is another way. So another way to graph a line is to find the two intercepts. The x-intercept and the y-intercept. The x-intercept is always found where y is equal to 0, and the y-intercept is found always where x is equal to 0. Always. Now, so what? You're probably thinking. Well, based on that, once we can figure out for any line what the x-intercept is and what the y-intercept is, there's our two dots. We can connect the dots together. We have our line, and we're done. So this is another trick method, another quick way to graph without using a table of values. And here, so this is useful for equations looking like this. When you have an equation that looks like this general form, Just like y equals mx plus b was a general form, the m and the b stood for something. Same thing here, the a, the b, and the c stand for some other number. So this is what's called standard form, or called ax plus by equals c. If it's in this form, it could be a minus sign here too. Then you could use the this x and y intercept method. Actually, you can use it for other lines as well, but it's usually when you have equations like this, you want to use this method I'm about to show you. And we'll type there. Okay, so let's take a look at example number 1. Here is an equation. It's a little different than what you're used to. 2x plus 3y equals 6. And in previous lessons, I showed you, if you want to use a y equals mx plus b, you want to get y by itself. But if it's in this form, you can leave it like that. And here's what you can do. We want to find what is the x-intercept and what is the y-intercept of this line. So what we want to do is we want to find the x-intercept. And how do you find the x-intercept of this line? Remember, the x-intercept is wherever y is equal to 0. The x-intercept is somewhere on the x-axis, and that's where y is equal to 0. So the x-intercept, again, where y is equal to 0. So all we do is we sub in 0 for y in this equation, and we solve it. So y is equal to 0, so we're going to put 2x plus 3, and we're going to sub in a 0 here, put it in brackets, whatever you're subbing in, equals 6. 3 times 0 is 0, so that just completely vanishes, and you're left with 2x equals 6. 2 is multiplying the x, divide by 2, the x is canceled out, x equals 3. So we just figured out, when y is 0, x is 3. And that gives us a point on the graph where x is 3, remember the x's go first, x is 3, y is 0. That is your x-intercept. So we know that's 1 point on the graph, 3, 0. 3 on the x, 0 on the y. So that's our x-intercept. For our y-intercept, what we're going to do is just change things around. For the y-intercept, we're going to figure out where x is equal to 0. So instead of that, we'll put x equal to 0. So now you find the y-intercept, where x is equal to 0. So wherever you see an x, you're going to put a 0. So 2x, let's put a 0 there. So 2 times 0 plus 3y equals 6. 2 times 0 is 0. That's the whole point. When you put a 0 there, it blows the whole term up. It's gone. You're left with just 3y equals 6. Now it's just algebra. 3 times y. Get rid of the 3 by dividing by 3. Same to the other side. Y is cancelled out. Y is equal to 2. So there's our second point we just figured out. When x is equal to 0, y is equal to 2. That's our y-intercept. So 0, 2. And then you draw the line. I'm going to do the lazy non-ruler line. You should use a ruler. There it is. That's the equation done. Our 2 points. We have our x-intercept and y-intercept. That's all you need. Draw the line. Done. Okay? So let's try another one of these guys. How about 4x minus 3y equals 12? The y equals mx plus b method you could use for this, and some of you might be able to figure out a way to do it, and good for you. But if you see this with numbers in front of each variable, coefficients in front of each variable, you can use this x-y-intercept method. So first, we want to find, doesn't matter which order actually, let's find the x-intercept first. Remember the x-intercept, I'm just abbreviating, it's intercept, is where y is equal to 0. So when is y equal to 0? Well, let's put a 0 in there. So 4x minus 3 times 0 equals 12. The 3 times 0 vanishes. You're left with 4x equals 12. Divide by 4, divide by 4, x equals 3. So your x-intercept is 3 on the x, 0 on the y. Remember, the x's always go first. 3 on the x, 0 on the y. So your x-intercept, I'll label it this time, is 3, comma 0. So 1, 2, 3, comma 0. Was the last one like that too? I don't think it was. Now we're going to do the y-intercept. So let's just get rid of all that. Do the same thing for the y-intercept. Some of you can probably do this in your head. You're thinking, I don't have to write all this stuff out. I already can do this in my head. Good for you. So the y-intercept is where x is equal to 0. So we put a 0 into there. 4 times 0 minus 3y equals 12. 4 times 0 is 0. You're just left with, don't forget about the negative sign, negative 3y equals 12. Negative 3 is multiplying the y, divide by negative 3, divide by negative 3, the negative 3's are gone. Y is equal to, signs are different, 12 divided by negative 3 is negative 4. So there's our y-intercept. Our y-intercept is, where x is 0, y is negative 4. And then we plot that, 0, negative 4. There's our second dot. Connect them, there's our long line. Done. Okay, moving along. Let's go to this one here. It's easy. You're just what you're doing is you're blowing up the x's to figure out what y is equal to, and then you blow up the y's to figure out what x is equal to. That's it. So to find the x-intercept, remember, to find the x-intercept, the point where it crosses on the x-axis, you make y equal to 0. So y is equal to 0. So when y is equal to 0, you get 4x, 5, y is going to be 0, equals negative 10. The 5 disappears. You're left with 4x equals negative 10. And some of you are starting to freak out. Oh my god, I'm not going to get a whole number. I'm going to get a fraction or a decimal. Yes, so what? Quit being such a wuss. Go with it. Divide by 4. Divide by 4. X is equal to 10 divided by 4. And if you're that afraid of what 10 divided by 4 is, having to figure it out, it's 5 over 2, which is 2.5. Or use a calculator. 10 divided by 4 is 2.5. Negative 2.5, right? Because that signs are different. Negative, positive. So it's negative 2.5. Don't be afraid of decimals. They can happen once in a while. So our x-intercept is negative 2.5, comma 0. And now our y-intercept is going to look like this. Y-intercept is where x is equal to 0. So this 4 blows up. So you have 4 times 0 plus 5y equals negative 10. This blows up. You're left with 5y equals negative 10. 5 times y, you're going to divide by 5, divide by 5. The 5's are gone. Y equals negative 2. So your y-intercept is going to be, when x is 0, y is negative 2. We plot those 2 points. So our x-intercept, negative 2.5, which is, there's 2. 2.5 would be right there, and 0 right there is our first dot. And that's negative 2, that's 3, so halfway in between, 2.5. Y-intercept is 0, negative 2. Let's connect that up. Finished. How about this? We did questions like this using the old-fashioned table of values method. And then I showed you, when it's like this, you want to get the y by itself, and you could use the y equals mx plus b method. You can also use this standard form ax by equals c method. It's just, what's the number in front? It's an imaginary 1, an imaginary 1, and an 8. It's the same story. What's the x-intercept? The x-intercept is when y is equal to 0, so we make this 0. X plus 0 equals 8. Obviously the 0 is gone. You're just left with x equals 8, and x equals 8. That's it. Remember, the x-intercept is where y is equal to 0. So when x is 8, y is 0. So that is our x-intercept, is x 8, y 0, like that is that right there. Okay, and then really quickly, do I have to do this one? Y-intercept, if y-intercept is where x is equal to 0, if I make that 0, that means it's gone. What am I left with? Y equals 8. So the y-intercept is 0, 8. Because remember, x-intercept, sorry, the y-intercept is where x is equal to 0. So 0, 8, and we can graph that line there. Done. See how fast this is? Okay, last one. How about this? Look at all the negative signs. It's crazy. Okay. X-intercept. Let's do that for x-intercept first. If you want to do the y-intercept, go right ahead. I don't really care. What do you do first? X-intercept is where y is equal to 0, so y is going to be 0. Negative 10 x minus 3, and that's 0 equals negative 15. That's gone, and we're left with negative 10x equals negative 15. Okay, and now when you divide, because negative 10 is multiplying the x, divide by negative 10, divide by negative 10, the 10s are gone, x is equal to 15 divided by 10. Negative 15 divided by negative 10. Signs are the same. It's going to be positive. 15 divided by 10 is the same as 5 divided by 2. Sorry, 3 divided by 2. Sorry, 3 divided by 2, which is 1.5. Use a calculator if you need to. So, y is 0, x is 1.5. So at x 1.5, 1.5, y is 0. Look at me not writing it up here. I'm being a rebel. And we do the same thing for when y is equal to, well, when we're doing the y-intercept, x is equal to 0. So for the y-intercept, x is equal to 0. So this becomes 0. Now, do I have to write it out? No. When I make this 0, this thing blows up. So what am I left with then? I'm just left with this, negative 3y equals negative 15. So negative 3y equals negative 15. Divide by negative 3, whoops. Divide by negative 3, 3's are gone. And again, 2 negatives is positive, it's 5. X is 0, y is 5. X is 0, y is 5. There's our fairly steep graph with the lousy line. You'll do better. Done. So another method to draw graphs from just an equation. Here are your skill testing questions. There are 4 of them. So what you got to do for each equation is find the x and y intercepts of each lines. Label them here. So like something comma something, something comma something. Whoops. For them all. And then if you could use one graph to save paper, use one graph and label and draw all these graphs and label which one is which. Not with the numbers, but with the actual equations. Okay, that's it. Thank you, bye.